The parent function for the family of square root functions is f of x equals the square root of x. The domain is all reals, but they have to be greater than or equal to 0. Because I'm not going to work with imaginary numbers here. So x has to be greater than or equal to 0. And the range is then y is going to be greater than or equal to 0 also. If I'm sticking in positive numbers, I'm going to get out positive numbers with the square root. The parent function for the family of cube root functions is, let's put this here, I forgot to put it in there, I think it got erased or something, cube root of x. That goes in that little spot right there. The domain and range are all real numbers. There are no restrictions for cube root. Okay? All right. So this is the process for graphing. Graph y equals the square root of x and state the domain and range. We're going to make a table for x and y. Oh, again. Always start with the first 3 perfect squares. Always start with the first 3 perfect squares. What are the first 3 perfect squares? Well, we're going to use 0, 1, and 4. That's what I want you to use. 0, 1, and 4. What's the square root of 0? What's the square root of 1? What's the square root of 4? Okay? Now I'm going to graph these points. 0, 0, 1, 1, 4, 2. Be comfortable with that because that's the parent function of the square root. So it's always good to be able to do that fairly quickly. And you can just do it in your head. 0, 0, 1, 1, 4, and 2. That is your parent function. And nothing else is happening to this function right here. It's just the square root of x. All right, what's the domain here? The domain, if you look at the x-axis, the x values are all greater than or equal to 0. They're all reals greater than or equal to 0. Are there any negative y values in this parent function? No negative y values, so the range is also greater than or equal to 0. Okay? All right, now we're going to start adding some things to it. All right, to graph y equals a times the square root of x minus h plus k, we've seen a, we've seen h, we've seen k before. H causes horizontal movement, k moves up and down, and a is a vertical stretch or shrink. Yes? We've seen all those before. Cube root, same thing. There should be an a here. Put an a in front of there. Okay? All right, step 1. You're going to multiply the y's by the a value. Step 2, you're going to translate the graph. That means left or right or up or down. H units, and it becomes the opposite, and I'll show you what I mean in a minute. H units horizontally and k units vertically. So what I want you to realize here is that a and k affect the y's. A and k affect the y's. A causes a stretch or a shrink, which will make the y's grow or get smaller, and k causes it to go up and down. All right, so we're going to graph this, then state the domain and range. First, make the basic table for your parent function. I want you to do that. It's an important step here. 0, 1, 4, 0, 1, 2. I'm going to graph my parent function real quick. 0, 0, 1, 1, 4, 2. There's my parent function. Now I'm going to use my different color. The second step says multiply the y values by 3, because 3 was my a. Multiply the y values by 3. So I'm going to put right here a little times 3. Those are my y values. I'm going to multiply them by 3. I'll show you where I'm going with that in a minute. Translate the graph h equals 1. See right here, h is 1. It's not negative 1. because it started with a negative, right? So that is a positive one. And k is 2. Stay with me. So that means that we shift the graph right 1 and up 2. So now let's do all this business, okay? First of all, we multiply the y values by 3, and we have to add 2 to our y values because a and k affect our y values. Then we have to go to the right one, so I'm going to add 1 to my x values. I'm going to make a new table now. My new x and y values. 0 plus 1 is what? 2. Seriously? 1 plus 1 is 2. 4 plus 1 is 5. Those are my new x values. All I had to do was add 1 to each of my x values. Then I got to multiply my y values by 3 and add 2. So 0 times 3 is 0, plus 2 is 2. 1 times 3 is 3, plus 2 is 5. 2 times 3 is 6, plus 2 is 8. Those are the new coordinates of my function, based off the parent function. So let's graph those points. See how it looks differently. See if I can get it brighter. Okay, over 1 up 2, over 2 up 5, 1, 2, 3, 5, over 5, 1, 2, 3. Something like that. That's my new function. That's my translated function. Now, starting here, my x values are all what? We don't get out of here until 149, so don't get antsy. Okay? My x values are all greater than or equal to 1, so that means my range has to be greater than or equal to 1. My x values are all real numbers. The domain are all real numbers greater than or equal to 1. The range, see here it starts at 2, and it goes up from there. So the y values are all reals greater than or equal to 2. You have to base it off your graph. We got more.
Yay! No.
Okay, let's do another one. So this will be a little quicker. First I'm going to identify my h, which is -3. My a is -1/2, and my k is 2. Don't pack up, it's just annoying. I'm going to hold you to the end this time, okay? All right. H is -3, a is -1/2, and k is 2. So let's make our original table. X, Y, 0, 1, 4, always 0, 1, 4, 0, 1, 2. Graph that. There's my parent function. Got it? Okay. These two affect my y's, so I got to multiply my y's by -1/2. And do I add or subtract 2? Add 2. And then I have to subtract 3 from my x's. So I'm going to put -3 here. You can extend it if you want, whatever. Then I would make your new table. Make a new table. You say, wow, it's a lot of work. Yeah, but you might have to do this without a calculator on the test. So I'm subtracting 3 from all my x values. Multiplying my y values by -1/2 and adding 2, and you get this.
Where's the second?
1.5. 1.5. Okay, let's graph these. I know, it's -3 up 2. -2, 1.5, and 1 and 1. So this is kind of a weird little function like that. It goes like that. Domain, where do the x values start? -3, right? And they're all bigger than that, so it's all my reals greater than or equal to -3. Range, the y values start at 2, and it's everything below that, so it's all reals less than or equal to 2. If I were to say in words what happened to this, I would say it was a shift up of 2, left of 3, and a shrink of 1/2, and a flip because of the negative. Correct? Do you remember all that? Should we start with the cubes tomorrow?
Yeah. So does that mean we don't have to tomorrow? We don't have school tomorrow.
Oh! Okay, let's just talk about how we would describe the transformation here in words. So you might want to say, you could start from here and say, okay, it went up 2, left 1, left 3. So I usually look at the starting point here. Here's the starting point, here's the starting point. I went up 2, left 3, which you can see right here in H and K. And then it was a shrink of 1/2 because this number A is less than 1, between 0 and 1. Shrink of 1/2. And because it's negative, it flipped. So I would just say a flip. So that's kind of one way to say it in words if you had to describe it in words. All right? So let's talk about this. We have to graph a cubic function and state the domain and range. So the first thing you're going to do here is the same thing we did before. Make a table of values to sketch the graph. So I'm just going to make my x and my y. And what you should do is use the positive and negative first 3 perfect cubes. Okay, so first 3 perfect cubes are 0, 1, and 8, but I want to use the negative version as well. So I'm going to do -8, -1, 0, 1, and 8. Take the cube root of each of those x's. Cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0, 1, and 2. And since it's a cube, it's going to be a snake, sort of emulates a line. So let's graph these points here. This is 8, -2, -1, 1, 0, 0, 1, 1, and over 8 up 2. So that is your parent function. That's your parent function right there, the cube root of x. And as I said before, the domain of any cube function is always going to be all reals, and the range is all reals. Anything could go in for x, and anything could come out for y. Always real, always all real numbers for cube root functions. All right? All right, now let's take it a little further. We're going to do some things to that cube root of x. So, remember this is your A, your H is here, it's the opposite, and that's your K. So the first thing I want to do is have you make a basic table. Oh, it just got dark. Let me see if I can make it brighter. I don't know why it got dark. All right, make a basic table for the cube. So here we go, x, y. You're going to use the first 3 cubes and their opposites, so -8, -1, 0, 1, and 8. -2, -1, 0, 1, and 2. So you're going to graph your parent function, 0, 0, 1, 1, -1, -1, 8 and 2, -8, -2. There we go. Okay, there's your parent function. Now let's see what happens to it when we consider all these things that happened here. So you multiply the y values by -2. So I'm going to write times -2. Translate the graph. So horizontally we're translating it. If this became a positive, that means it was a -3 that went in there. So we're going -3. And this is a -2, which means it went down 2. K is -2. So we shift the graph left 3 and down 2. Shift the graph left 3 and down 2. Okay? So let's make our new table based on what happens here. But first I'm going to fill in here. Remember, the horizontal translation affects your x values, so you've got to subtract 3 from all your x values. We're already multiplying by -2. We also have to subtract 2 from our y values. So let's make a new table, considering those things happening. So -8, take away 3 is -11. -1, take away 3 is -4. -3, -2, and 5. All right, -2 times -2 is +4. Take away 2 is 2. This is going to be 0, -2, -4, and -6. So if I were to graph those points, I'm going to go ahead and do that. -11 up 2. -4, 0. -3, -2. -2, -4. And over 5 and down 6. So it's still a snake, but you can tell it's been stretched a little bit. It was flipped, and it was shifted left and right and down. It was shifted left and down. So sometimes I like to just look at the center here, and the center here, and you can see that it went left and down. So it went left 3, down 2, which makes sense with my H and K. Makes sense with my H and K up here. Okay? So if I had to describe it in words, this is what I would say. It was shifted left 3, down 2. It was a vertical stretch of 2 and a flip because of the negative. So it was a flip because of the negative. So sometimes it's good to be able to say it in words. Let's do another one without graphing. Compare in words the graph of y equals 3 times the cube root of x plus 2 to the parent function. So a is 3, which causes a stretch. There's no flip because that's positive. Plus 2 just causes it to go up 2. There's nothing else, there's no h in here. So there's no horizontal movement, no left and right shift. So I'm just going to say a vertical stretch of 3 and up 2 is what happened. And that's all you would have to say in words. Okay, that's it.